In this tutorial, we'll show you how we can expand the composite pattern to support the visitor pattern. So this is what we have achieved in the previous tutorial. We have the deferred class called expression, and we got two descendants classes that are effective, which means they are not deferred. Constants for the base case, and we got addition for the recursive case. And also the addition makes use of the multiple inheritance in IFO. So addition is an expression, also addition is a composite. And what we did was composite was completely generic. And then addition is a special case for composite where the number of children is simply just 2. So now the extension we will do in order to extend the composite pattern in order to support visitor would be, so this is the package or the cluster for the structure for the small expression language. And then we're going to add a new feature at the expression class level, which means this feature here will be inherited to all the descending classes for the expression. So this is called accept. The accept is going to accept something called V of static type visitor. And because of polymorphism, the dynamic type of this visitor V here can be any of the descendant classes of visitor. Okay. And now, for every effective descending classes over here, we have to implement this accept feature over here. But the implementation should be very straightforward. I'll show it to you. And then, in another cluster over here, you can think of for every operation that we'd like to perform on the expression language, we have to convert that into a class. Okay, so now for the visitor over here, so that's the upper level class, and this should be deferred actually. Okay, that's a typo. This should be deferred. And then we have visit constant and visit addition. The number of features we have in the visitor depends on how many descending classes we have for the expression in the structure cluster. In this case, we got constant, we got addition. That's why we got visit constant and visit addition. And then the parameter type here must be exactly the same as the corresponding descending class. If we simply put expression over here, so that means the static type for expression is not very useful, because in the case of visit constant, we would like to access the value attribute over here, but value is only available at the constant class level, not the expression class. So if you only put expression over here, you're going to do an explicit cast, which is not very recommended. You should only try to eliminate the need for cast if possible. Okay, and for every operation that we have for visitor, for this tutorial, we only illustrate how you can do evaluator. Okay, how you can evaluate expression recursively, especially in the case of the visit addition. Okay, again, for the expression class, we only support this accept feature here, and then for the visitor, we have to support the features that will let us handle all the descending classes of expression. Okay, let's now do it in IFO Studio. Now launch your IFO Studio, and let's go back to our project here. So now, first of all, let's go to the expression class. Let's go to operation class first. Okay, operation class a cluster, and then we'll have a new deferred class. Okay, you can say visitor, and then let's choose that to be deferred over here and creates. Okay, so now in the visitor class, we only have we have the features. Let's say feature. Okay, visit features for all effective. Effective simply means they are not deferred for all effective descendants of expression. So which means we have something called visit constant, and then so over here we have C of type constant. And then we do something here. I will do this implementation in a moment. And also visit addition. Okay, over here also A of type addition. Okay, so let's make sure things compile. Okay, it does compile. So now these are, oh, actually this is deferred class. Sorry, I forgot. So now these two features must be deferred because we simply don't know what to do at this level. Okay, defer end. Okay, let's just do a little bit more properly. So which means we don't have any implementation at this level here. And then let's put defer as well. And then when we create concrete descendant classes like evaluator, we have to implement these two features over here. But we'll do that in just a moment. Okay, that compiles. Now let's go back to our structure cluster over here, and let's go into expression. Okay, now we're going to extend it by one feature. Okay, so now this is accepting a visitor for operation. So now here we're going to say accept over here, and then v of type visitor, and then again it's deferred. Okay, as you can see, what we have done, we added visitor class over here that should be deferred, and then we have visit constant, we have visit addition, and we also extended expression class with accept. Okay, now let's go to implement the accept for constant and addition first, and then we'll go to visit constant and visit addition for evaluator. Okay, now let's compile, and then now you will see that compiler tells you that you actually have the addition class inherits from expression, but you have not implemented this accept feature, which is deferred. So we're going to do it. And similarly for constant class. Okay, let's go to constant class first. Okay, let's go to constant class over here. So we got to define the feature for visitor. Okay. Okay, feature and then visitors. Okay, so now we can say accept and then v of type visitor. Okay, so now this means okay, now I will simply say the current constant accepts a kind of visitor v. Okay, depending on the dynamic type of v. Okay, how about this? The dynamic type of v will determine the type of operation to be performed on the current constant objects. Okay, that's something you can just to convince yourself that's the case. Okay, and then we'll do debugger maybe in the next video. Okay, so now let's just do the indentation a little bit better. Okay, over here. So now we can say v dot visit. So now what should we visit? We got two choices. Remember, in the visitor class, we got visit constant or visit addition. Now, because now we are in the context of constant class, so we should say visit constant. Okay, and then we should pass a constant object over here. And now we want to pass the current objects to be visited. So current. Okay, then let's compile. Okay, so now we're still left the implementation for accept in the addition class. So let me just copy this block of code and I'll modify that accordingly. Okay, let's now go to the addition class over here, and then we'll do over here. Okay, just right before the invariance. Okay, visitors, the current addition objects accept a kind of visitor v. Dynamic type of v will determine the type of operation to be performed on the current addition objects. Now you can see that if I try to compile, it wouldn't compile because you can see if I say visit constant over here, I pass currents. What's the type of current? Current is addition. But now if you go to the visitor class, you can see that visit constant is expecting some constant, but you're passing addition. Of course, that's a good thing. That's a beauty about type checking. It tells you there's something wrong. So what we should do is we should just do the corresponding visit operation, visit addition. Okay, that's what we should do. Now compile, everything compile. Okay, so now what's really left is we have to define. So far we only got the upper level visitor defer class, but we want to make sure we got at least one operation for us to make use of, so we can write some test about it. For the moment, we only got this, and nothing can be the dynamic type for visitor because visitor is simply deferred. Again, this is a typo. That should be a star. Okay, so let's go to the visitor cluster over here, and then let's create a new class. Let's call it evaluator. And then the parents over here, let's try. We can say add And over here, we can simply, I believe we can simply choose something here. If we cannot, we can try. Okay, it seems like we cannot. Okay, never mind. Okay, just cancel. Okay. Now let's just create. Okay, create again. Let's call it evaluator. Okay, creates. Now evaluator. Now when we say inherits, you can see evaluator should inherit the visitor. Okay. Now as soon as we say compile, you will see that what's really wrong is in the visitor class we got visit constant, visit addition, but now we haven't defined them yet. Okay, so for any features that you inherit from a deferred class, if you choose not to implement them, that means your current class must be deferred as well. But that's not what we want, because we want evaluator to be a valid dynamic type at the runtime. So that's why evaluator should be effective, which means all the inherited deferred features must be implemented. Okay, that's what we'll do. Handling of expression descendants. Okay, let's do that. Visit constant, and we also have visit addition. Okay, that's what we have. Okay, so now for evaluator, because we know that the result for the evaluation should be an integer. So we can, for this particular class, we can actually try to declare some additional storage attribute for us. Okay, let me just also put my name over here. Okay, so now let's do the following. So now feature evaluation result. Of course, depending on the kind of operation you have, you can actually store the result store the result as an attribute. So the attribute can be called by any other clients who's using the evaluator or your visitor. Okay, so now I'll just say you can either call result or value. Okay, let me just call it result. Actually, result is a keyword, so I cannot use it. What about eval result? Okay, just more explicit. It's integer. Now, so here we're going to say when we are trying to visit a constant. Okay, let me just try to compile. Yeah, so I should really declare also. It's a constant, so C of type constant. Okay, again, you should really refer to this architecture here. Visit constant and visit addition, so the types should be correct. Okay, and now we also have visit addition here, A of type addition. Okay, let's compile. Okay, everything compile. Let's now implement the visit constant, visit addition. Visit constant should be easy because constant, remember, if you see the pattern here, the composite pattern here, constant is the base case, which means we should not need to visit any further other than the constant itself. But in the case of addition, we have to make sure we visit its left and visit its right before we can know how to add up the result together for the current addition, right? So now let's try that. So now for visit constant, we can simply say the result, actually not result, the evaluation result for this current visitor evaluator should be, because we are visiting a constant, we can simply say this is assigned to C. Okay. On the other hand, for this visit addition here, we got to do this recursively. Okay. Let me just give you the code, and then I'll write a test case, make sure you pass, and then in the next video, I'll show you how you can see the effects at the runtime using debugger. So local here, and then we can say evaluator left. I can define some auxiliary visitor. Okay, eval left, evaluator, and also eval right. Evaluator. Okay, so now I can do left and right. Okay, I know the left hand side, so now I can say a.left. So this is an expression. So now in the expression, what do we have? Remember, in the expression class, we have the accept feature. Okay, that's what we can call. Also in the architecture diagram, you can see expression has been extended with the accept feature. Okay, I can say a.left.accept. But now, what kind of visitor do we put? Okay, let me just do it again, so you can see the signature there. So now, what kind of visitor should we put? We can put any visitor as we like, but we should better put the one that can give us the result later. So this is that, And also we can do the same for the right. Dot accept. And now in this case, eval right. Okay, once we got this, we know that for every evaluator, we actually support the result called eval result, right? So that's why we can say the eval. You can think of it this way: current, which is like this in Java, the eval result. So this is the current visitor we're talking about. The current visitor is visiting an addition, and then that visitor here is delegating the job into two auxiliary visitors. One is called eval left, the other one is called eval right. So after these two visitors have visited the left and the right, we can call their eval result feature, right? And then to figure out. Okay, so you can say eval left dot eval result plus eval right dot eval result. Okay, that's what we have. Let's make sure everything compile. Okay, if not, then we'll figure it out. Okay, accept eval left. In this case, there should be a visitor. Did we actually got evaluator inherits visitor? Let's have a look. Okay, so now we should actually, okay, what's happening here is, actually that's again for voice safety, because we're passing eval left over here as an evaluator, but now we have not initialized the evaluator. That's why. Okay, we can say creates. Okay, so now we can do the following. We can simply say creates make feature constructor, and then we have make over here. Let's say we simply just do nothing. Okay, or if you like, you can explicitly initialize the result to be 0 default. Okay, let's try again. Okay, syntax error. Let me just create over here eval left dot make, and also create eval right dot make. Okay, let's try to compile. Okay, let's see. Now eval result over here, what we gotta do is eval result over here, it's actually an attributes. So what we gotta do is we want to make sure this, okay, is assigned to, so if I simply do this, that's an attributes. Okay, let's compile. Okay, and then eval result is simply equal to c dot, sorry, this is what should be c dot value. Okay, there's several typos from before. Now, we said the eval result should be equal to the value for the constant, so that it should be, rather than just c itself, c dot value. Okay. Okay, and then just make sure you don't put a current at the front. So basically we're saying we're calling the attributes. The attributes is the eval result, which is the eval result for the left evaluator and also eval result for the right evaluator. Okay, so now everything compiles, and now we are ready to write some tests, and then we'll see if things work, and then in the next video I'll show you how to see the visitor pattern working at the runtime using debugger. Okay, let's now go to test operations over here. Okay, now let's say over here test, okay, what did I say over here before? And just be consistent with my naming as before. We can say test expression operation. How about that? Okay, over here, so now what we have is, let's go to test operation here, and then let's copy that, paste, and then operation. And in this case, only evaluator. Okay, do and end. Okay, now in order to use the visitor, we have to build out the composite object structure first, pretty much like how we did in the test structure over here. Let's do the same thing. Okay, let me just do some copy and paste. First of all, let me use local over here, and then we have that. Okay, so you should be familiar with this particular expression over here. Okay, so let me also put a comment here. Okay, and then, okay, let's go back here. Okay, over here we'll simply say test expression operation and then evaluates. Now rather than construct, we're going to evaluate. Okay, so now let's create that. Okay, so first of all, we can say creates, so constant e1 dot make and then 2, and then creates c constant 2 dot make 3, creates constant 3 dot make and then 6. And now what we have is we can say addition. Let's say this is the second level addition. This is the first level addition at the top. Okay, so now we can say creates a2 dot make, and then the left should be e1 over here, right? So this is e1, and then c2, and then we can say creates a1 dot make, and now the entire a2 is the left of a1. Okay, we have seen this. If you have a question about this, you can refer to the previous tutorial about composite. Okay, and then we can say c3 over here. Okay, so now this is the structure. Now, how do we evaluate this? First of all, let's simply do something simple. Can we just evaluate? Let's evaluate two things. Let's first of all try to evaluate just the simple case. Let's say, let's put an evaluator over here. Let's say evaluator. Okay, and let's try that. Okay, first of all, let's try evaluate a constant. For example, I can simply say evaluate. I can say e1 dot accept and then eval. And I know that e1 is actually of constant value 2. So now I can say result is assigned to eval result is equal to simply just 2. And check result n. Let's try this first. Okay, let's see what happened here. Okay, I think it's because we haven't created eval yet. Okay, always forget. You should always remember whether that's a local variable you have over here or when you have something that's an attribute, you always you should always try to initialize them before you use it. Because now I'm trying to use the eval over here, but I did not initialize it. Okay, you will see that over here, the error message over here is saying that the evaluator that we are passing is detachable. Detachable, if you refer to the voice safety lecture, detachable simply means this expression eval over here can be void. Void simply means null. It can be null reference pointing to nowhere. Okay, that's for then you might have some null pointer exception at the runtime. Okay, now we can simply create eval.make. Okay, and now we compile. Okay, now everything compiled. Okay, so now let's run the tests. And now you can see that test, oh, we haven't added a test, have we? Okay, let's do that quickly. So now we can add Boolean case and then agent test expression operation. Okay, now you can see that if we run the overall, the application over here, it has also the test operation. So now it will work. Now if you say run workbench system, okay. Oh, one more thing. Okay, something I forgot. If you go to the test structure here, can I also have you copy and paste this over here? Okay, and then we'll go to test operations over here, and we're going to do this as well. Okay, compile, and then do it again. Okay, so now I believe we got 2 web browser brought up. Okay, let's fix this very quickly so we can combine the result. So now maybe comment out this show browser over here for test operations. Go to test structure over here, also comment this out over here, and now go to the top level application over here. Let's put a show browser over here. Let's try to see if that will work. And then compile. Okay, run and then run workbench system. Run espec. Let's see if that will work. Okay, that's how you do it. Okay, basically what you want to do is you want to say show browser here and also run expect. Okay, that's what you're going to do. Okay, so now if you run it, run workbench system, so now you actually got two tests over here. So the first one is from testing the composite pattern. We just make sure the things are being constructed properly, and then we also try to evaluate. Okay, let's go back to our test. Let's do a little bit more tests. Test operations over here. So we just evaluated the constant. Let's also evaluate the, let's say E1. Let's say we want to evaluate this addition here, the simple one, this addition over here, okay? So you can see this addition here, the left is a constant, base case. The right is also a constant, also base case. Okay, this is A2, okay? Remember, this is A2, okay? What I can do is, I can say E1, A2, okay, that's the expression, and then accept. I can say accept the same evaluator, so it's going to override the result from the previous evaluation. So I can say result is assigned to evaluation result, and this should be 2 plus 3. Okay, so that should be 5. And then check result n. Okay, compile. Okay, let's run it. Okay, that also passed. Okay, so far so good. Let's do one more. And now we can also say A1. A1 basically is the whole thing. Okay, this one will take some effort to actually take some explanation to see how it works at runtime. I'll cover that in the next video, but let's finish the test. Okay, so now we can say A1.accept and then eval, and then here we can say result is assigned to eval.evaluation result, and that should be, now you can see 2 plus 3 plus 6, so that'll be 11. Check result n. Compile, and then we can run, and then run workbench system. Okay, so now everything passes. So now what we have achieved was we define the visitor class and also its descendants. Also, we extended the expression class with the accept feature over here. And then for every concrete or effective descendants of expression, we also implemented the accept feature over there. One in addition, and also one in constant, like here. Okay, and also you should really review the architectural diagram that we have over here. That's exactly what we did. Okay, now in the next video, we're actually going to show you how the pass test was executed at the runtime using the debugger. Okay, stay watching.